Alright, today's lesson is 5.5, simplify. Complex rationals. Alright, example 1. 3 plus 1/6 over 1 minus 3/8. So now you have no new skills, but you're combining, you're adding, and you're multiplying and dividing. And you still have all that factoring in here too. So this is going to be a lesson that combines everything together. Okay, so in the numerator, this is really like over 1. So I need a common denominator between a 1 and a 6, so that is a 6. So that means this would become an 18. And this didn't get changed. All of that is going to be over. So 1 is really over 1. So both of these need to turn into an 8 as a common denominator. So what did I do to this? Multiplied by 8. What did I do to this? Nothing. Okay? Let's simplify things. This is 19 over 6 divide by 5 over 8. Okay, rewriting again. 19 over 6, instead of dividing, I'm going to multiply. What am I going to do to the second fraction? Flip it. Okay, anything can reduce. I see something. I can reduce this by 2. So if I take a reduction of 2, this would become 4. Reduced by 2, that would become 3. So your final answer is 19 times 4, which is 76 over 15. Okay, so no new skills, but it is a lot of organizing your other skills. Okay, example 2. 4 over 8x. Plus 2 over x over 3 over 4x minus 1 over 2x. Okay, numerator. 8x and x, common denominator, they both fit into an 8x. So I'm going to do nothing to this first fraction. This one I would have to times by 8. So 16. 4x and 2x, I would need a common denominator of 4x. They would both fit into that. So do nothing to that. In order to change this to 4x, I would times by 2. So now my top would be also become times by 2. Alright, collecting stuff. This becomes 20 over 8x. And I'm going to make this division a multiply, and I'm going to flip this around. So the 4x is going to go on the top, and 3 minus 2, which is 1, is going to go on the bottom. Okay, reduction. 4x and 8x can both be divided by 4x. 4x is cancelled. Divide by 4x becomes a 2. And then I can see 20 and 2. I can, if you want, just mathematically divide those, or think if I cancel both by 2, it'd become a 10 and a 1. Okay, example 3. X over 3 minus 9 over 3x all over x plus 3x plus 3 over 3x. Okay. In this first part, 3 and 3x would both fit into a 3x. I would need to multiply this by x, so I need to multiply the top by x. I would need to do nothing to this one, so I leave it. So this now becomes x squared, subtract 9. Okay, let's look at the denominator. So I have 3x and 3x, So that is a common denominator. So now I just do nothing to this and nothing to this. So x plus 3. Okay, so now we have x squared minus 9 over 3x. Okay, remember this division? I'm going to change it to a multiply, and I'm going to flip. Okay, so I see here I have a 3x and a 3x. So we can cancel that. Do you see anything with this? X squared minus 9, I can factor that. Difference of squares. Okay, now I can also see an x plus 3 cancels. So my final answer is, this was what was left, and it's in the numerator. Okay, that's complex rationals.